All right, so Unit 6, we have two different things going on. We have this graph of F prime, where we have values of areas labeled. And then we also have this other function, g of x, to work with also. So for A, we want to find the value of the integral from 0 to 7 of f prime of x dx. And so this is the accumulation function. When we have the integral of an f prime, we're just accumulating areas. So any area that's above the x-axis, we are going to add, and any area that is below the x-axis, we are going to subtract. So the first area is 2, and it's above the x-axis, so we add. The second area is 7, below the x-axis, so we add, and then above we add, above we add. So that is going to give us an integral of -1. Okay, and let's look at the next one. So we're given information, so don't forget, this is f prime, so we're given information about f, that we know that f of 4 is 10. And we want to write an expression for f that involves an integral. And then we're going to use this expression to find the absolute minimum value of f and the absolute maximum value of f on the closed interval from 0 to 7. So let's just start with that expression. So for the accumulation, to find f, what we would do is take that f of 4 that we're given, and we're going to add the integral, and then these two numbers need to match. So from 4 to x of f prime of t dt. I hope you guys remember doing that. We did it a couple different times. So it's like you have an initial value, and then whatever that value is here, that lower limit matches it, and then we just go to whatever we're adding, like we're accumulating values on top of that 4. Now, if those numbers that we put at the upper limit are less than 4, then when we do our accumulating, we would need to subtract or use the opposite sign. All right, so now we are finding absolute maximum or minimum and absolute minimum and absolute maximum. So when we do those types of problems, what we do is we list out the candidates. And the candidates are going to come from the endpoints, which I know are 0 and 7. And then also place the critical numbers. And the critical numbers are the values where f prime of x is 0. Now we actually have 3, right? Yeah, 1, 2, 3. Now the thing about 6 is we could list it, it's fine, but it doesn't, it's not going to be a maximum or minimum because the sign of f prime doesn't change. So I'm going to leave it off because I know it's not going to be one of our values. So let's just go ahead and use 1 and 4. Now I may not have given myself enough room to write, but we'll try it. I'll squeeze it in here. Okay, so those are the candidates that are running for maximum or minimum. And then we're going to hold an election. And when we hold the election, we find their values at f. All right, now we know f of 4 is 10. So in the place of f of 4, we're going to put 10. And then we're going to add the integral from 4. And then whatever this number is, that's our upper limit of f prime of x, f prime of t, dt. Okay, so we're going to have the 10, and then the area for we're moving backwards from 4. So when we move backwards, we use the opposite sign. So 7 is below the x-axis, but because we're moving backwards, we would do the opposite sign. All right, and then 2 is above, this area 2 is above the x-axis, but because we're moving backwards, we're going to subtract it. Now we could have taken a step, I just don't have very much room. You'll have plenty of room whenever you're doing this on your test, because you can use your own paper. You'll have plenty of room, but we could also have changed it to minus and then switch our upper and lower limits. That should be a T. All right, however you do it, we do get 15 here. Okay, and then we'll do f of 1, so same thing. We're going from 4 to 1 of f prime of t dt. All right, so I know that's 10. All right, and then same situation. We're still going backwards from 4. So we would do the opposite of the negative 7, which would be plus 7. So that's 17. Okay, f of 4 is just 10. That's easy, because that's given to you. F of 7, we take that 10. We're going to go from 4 to 7 of f prime of t dt. So I have 10. All right, this time we're moving to the right. So we go ahead and just use the normal adding, or the normal signs that have to do with the problem. So I would take my 10, and then I'm going to add both of these areas because they're above the x-axis. All right, so that is going to be 14. Okay, now we do need to answer the question. So showing all that work was justifying. So we would say on the interval from 0 to 7, the absolute minimum value of value is all right, the smallest value here we have is 10, so we're going to say f of 4 equals 10, and absolute maximum value is, and our largest was 17, so f of 1 equals 17. All right, and then for C, we want to find the antiderivative of g of x. All right, so it looks like we're going to use the power rule for integration. So we're basically adding 1 to the power and then dividing by that new power. So I'll just go ahead and rewrite it. So the integral of 5 is going to be 5x. All right, and then we're going to add 1 to 2, and that's going to be 3, so we divide by that and add, and then that's our new exponent. And then don't forget your plus c, please. You get no point without the c. right, and then for this last one, we're going to find the value of the integral from 1 to 2 of x times f prime of g of x dx. Whew. Okay, so let's go ahead and just fill in g of x. Okay. So we are going to have to do u substitution on this, and I know this is kind of a very abstract problem, but the inside function is going to be 5 minus x squared. So I'm going to call that u. All right, so don't forget, we do du, find the derivative, du dx is going to be negative 2x. All right, and then when we solve that for du, we're going to get negative 2x dx. Okay, so we need to have negative 2x dx in the problem. Now what we have is x dx. So we need that negative 2. So I am going to multiply by it. But that changes the value. So what we would have to do on the outside is multiply by the negative 1/2. Okay, and then I'm ready to rewrite this. So I have this negative 1/2. And then we have the integral. Ooh, don't do what I almost did. So because now I'm about to not have any x's, I'm going to have all u's, I have to change my upper and lower limits. So everything has to be u's. So we would take 1 and we would plug it in for this x. So it would be 5 minus 1 squared, which is 4. And then we would take 2 and we would plug it in for x. So 5 minus 2 squared is going to be 1. All right, so what I'm going to do, I'm still going to have the f prime in the place of in the place of 5 minus x squared, I'm going to write u. And then in the place of what I have highlighted in green, negative 2x dx, I'm going to put du. Okay. So if you guys notice, the upper limit is smaller than the lower limit, so I can rewrite this. I can switch them, but when I do switch them, it changes the sign in the front. So it becomes positive 1/2 from 1 to 4, and then f prime of u du. Okay. So now let's look at this integral from 1 to 4 of f prime of u du. So remember, this is the graph of f prime, and that integral is going to be basically, we're going to look at this section right here. And so we're looking at that area, which is 7, and because it's below the x-axis, it's going to be negative 7. All right, and so that's going to end up giving us negative 7/2. So that used a lot of different aspects of integration to do